For sure. That's good. Thank you. Yeah, sure. So, my name is Abdullah, and I am a master's student at Memorial University of Newfoundland, Canada, and I'm working on photocatalytic conversion of CO2 to methanol. And I'm currently in my second year of thesis. And yeah, and as part of Ocean Startup Project, our team was selected for validating the idea of commercialization. So I proposed my project for commercializing, and we need to validate that idea and to understand it more and take insights and feedbacks from different stakeholders and regulatory bodies. So this is why we take up this meeting, and I really appreciate your time to take it. So and how about
So,
you?
yeah, let me introduce myself.
Yeah,
Can
sure.
you listen to me?
Yeah.
Okay, great. So, I'm PhD student. My name is Yanis Keroglou. I'm here in Purdue University in US.
Yeah.
I'm originally from Greece.
Oh,
My background is chemical and environmental engineering.
yeah.
So, I'm kind of related with carbon dioxide.
Yeah. Mm,
So, let me check because I
mm,
lost my camera. Um, yeah. So my background, uh,
yeah.
my background is mainly in life cycle assessments,
Okay.
techno-economic analysis.
Oh, that's great.
I worked like recently in a project related to director capture.
Okay.
Um, So I'm not really familiar with the specific technology that you are trying to implement. I know like the general process to produce the methanol
Right.
from the carbon dioxide. It's kind of interesting, especially because relate also to the ocean. So
Right.
there's a lot of potential there. My question is, have you done like any experimental process so far? Do you have like collect data from actual experiments, or is it like in a modeling scale so far?
No, this is like an experimental project. So I have done the project experiment on my in the lab, but those results are mostly at lab scale. So
Hmm.
I did the reaction myself using the photocatalytic reactor, but it is on
Hmm.
DI water, and then we use pure CO2 in order to make the CO2 dissolve in the water, and then we put the catalyst inside, which we
Hmm.
designed in our lab, and then the process of conversion takes place when we turn on the light. So there is a UV light and it gets converted to visible light. So
Hmm.
the visible light gets concentrated in the reactor, and
Hmm.
then it activates the photocatalyst. And this activation of the photocatalyst leads to the breaking of the water molecules into hydrogen and water, which is the hydrogen and oxygen, which is the water splitting reaction.
Hmm.
And that hydrogen takes part in the conversion of CO2. So as we know that we require six hydrogen electrons to produce
Hmm.
methanol. So this process goes on and this leads to the production of methanol. So this is what we do in the lab, and we receive good results from our lab scale, but we still cannot quantify it in a higher level, or we are not able to scale it up to the production level until we actually do it. For example, making scaling it up to 1 kilogram of methanol or
Do
one
you
liter.
do you have any sense of the cost?
Yes, so that's the second one which we face. So so this process is very low on cost because we require only visible light, and
Uh-huh.
we do not use any kind of electricity or another process in order to that would lead to a expensive process.
So the other question, so you have a solar system, as I
Yeah.
understand, or it's directly like from the. the sunlight.
Yeah, right.
Okay. So in this case, how can you like
Actually, we simulate the sunlight using using a UV light process. So this UV light actually converts into visible light. So we
okay,
just use a device which produces UV light, and then we use a filter to convert the UV rays into pure visible light, and then we use it. So yeah.
okay. So one question could be how can you like install a device like that in a larger scale? And how
Mm.
expensive can be a device like that with a UV in a larger scale?
Uh, I,
And
I
also, how feasible can this be,
I would
like in an open system like the ocean, that you have also some other phenomenon like waves and stuff like that?
Yeah, I would say you could use the direct sunlight instead of using that
Direct.
system. Yeah. So that sunlight, since we do not have sunlight here because it's this area,
Yeah, yeah.
yeah, this area is more like there's no sunlight for 6 months. So we just simulate it using the in the lab. So if you have sunlight, you could do that process.
Um, I think um, you should think also about the storage, energy storage, because you will not have sunlight like the whole day. Also, especially in Canada, there are many like periods, many months that it's really cloudy. I don't know how much will be the efficiency of the sunlight in order to activate the whole process,
Yeah.
but this is something that you have to check.
Yeah.
Um,
That's why we are more focused on doing the work globally rather than just focus on Canada in order to
that's good. That's
yeah.
good. Yeah, maybe this will be more feasible, like in countries that are south,
Yes, like the
south
Middle
and like
East, so they
eastern.
have more
Yeah,
sunlight.
yeah, exactly, exactly. For example, in Greece, I'm from Greece. It's something that could be feasible.
Right.
Uh, it's something that could be feasible. Um, Also, about the methanol, the production, the methanol is produced, right?
Right.
Um, what about next? Where do you store it? How do you utilize it from the source?
So methanol, so when, yeah, it could be used, so it acts as a liquid fuel product, and it could be used in shipping industry as a fuel by shipping
Hmm.
industry by ship vessels, or it could be used as a feedstock for production of other chemicals, and it
Hmm.
could also be used in cars. So Brazil actually is trying to integrate that process where they can use methanol in their system in the current infrastructure and run the cars on it. So this is the, and as we know that it's a liquid fuel, so it's quite easy to store.
Hmm. Um, Also, are there any byproducts from this
Mm,
process?
yes, there are byproducts from this process. This is what we focus on. We focus on the mechanism, on understanding the specific mechanism of the process. So we have byproducts such as carbon monoxide and
Okay.
methane, but those are very small range. And we have a little bit of hydrogen and also, if we improve the efficiency of the process, that that could lead to the production of ethanol.
Hmm.
Yeah,
Okay.
but those are
Okay.
very few compared to methanol because we we actually synthesize the catalyst in a manner that it leads to the production of methanol. So
Okay.
that photocatalyst plays the major role in deciding which product we get.
So one question that I have is, in the lab scale, I can understand like everything. You have the equipment, you have your catalyst, you can do whatever you want, like it's quick. When you go like in a system like in ocean, in the sea, how can you handle and like the whole process? I mean, it's a huge system. How can visually be a plant there, like a commercial plant? How could work? Like, should it be close to the coast? coastline?
Yes, so that would be more likely close to the coast where we actually take up the seawater and then do the process.
Okay, so it's okay, got it. So you get the seawater in the land and you do the whole process there. That's what you mean. It's like
Yeah.
the desalination. It's like a desalination,
Yes. Yes, that's
similar
right.
desalination. Okay,
Yeah.
okay.
So, do you have any idea on the shipping industry or the marine industry or the regulatory frameworks?
Kind of, kind
Okay.
of, kind of. Do you have any question specific?
Yeah, so I had specific questions like um w- when you think about methanol as an alternative fuel, what keeps you from moving faster on adoption?
Good question. Um, I don't know, to be honest. I think
Um,
methanol is a good option.
oh, that's great. And
The only thing that you have, yeah. So one good thing with the methanol on the way that you want to produce it is
yeah,
that compared to the conventional production,
yeah,
I feel that it will have much less environmental impact
yeah, that's right.
because the conventional production of methanol includes a lot of upstream impacts and emissions.
Yeah. And how about the regulatory frameworks like IMO? Mm, how does that play a role in actually leading to production of green fuels such as methanol?
Probably because there are many different like green approaches investigated right now.
Yeah,
I would say you have like to, in order to convince and to follow like the frameworks and the regulations, you have to check two major things. First, that the environmental impacts are
yeah,
limited and that you achieve like the least you can. And the
yeah,
second is that the cost is compatible, like competitive
right.
compared to the other options you have. So you have to maybe model, like make a model,
Yeah,
scale your processes, and
yeah,
see how in scaling is compared the cost between your lab scale and your industrial
right.
scale. So something like that is necessary before you go to the next step. I
Yes,
mean, it's difficult to convince someone without having like evidence that my emissions will be this with an LCA, life cycle assessment. My
yeah.
cost will be in this range. So it's stuff that you have to do before you try to scale up something.
Yeah, that's
And
right. But currently, we actually even plan to do the lab scale of the higher amounts, such as using 1 kilogram. But we face like restrictions on the equipments and all those the lab setup. So we do not have,
mm,
yeah, and we that would actually lead to costs. So we actually plan to receive fundings on it and then move on to scaling up the process because at this process I'm more focused on the mechanism. So this is
mm,
we're just trying to actually look on whether it can this could be done or not. That's the main purpose of the Ocean Idea Challenge and to validate it.
um,
Yeah.
is there like any company that you could collaborate with and like do your setup there and experiment there in a bigger scale, like a pilot scale?
mm, I don't I could not find any company nearby me which are actually working on a similar project or which are actually working on this. So
Okay,
that's the
okay,
challenge. Yeah. But
okay.
once we get the funding, we could try to do it in our own lab. So for one
Mhm.
kilogram of methanol, we could do that actually. That's something doable in the lab itself. But even the reactor which we get it at present, it's quite a delicate one, and it's we get it from China, so we do
Mm.
not get it
Okay,
from
yeah,
nearby.
it's
Yeah, so
complicated. Yeah.
yeah, it's complicated. So they are designed at a certain process. They have certain what they have certain quantity which they can hold, and um, we try to work on it more and more as possible. So in order to make the efficient process, so it's something at lab scale only. Yeah.
Okay. Okay, good.
That's
Do you
great.
have any other question?
No, that's all. No, no worries. So I was just wondering, like, if there could be some more people whom I could connect with, who can
Mhm.
perform a similar feedbacks, maybe in your own network, whom you could suggest.
Yeah, I will check. I will check and I will let you know.
Yeah,
Okay.
sure, sure.
But I mean, I couldn't give you like a really specific
No,
feedback,
it does not. It
but
does not. Actually, just a moment.
because I'm doing scaling